Hey guys, this is part 3 of our video series, it seems, dealing with pH calculations. So I've tried to break them up, kind of keeping them together. And now this last one is going to kind of tie things together. Up until this point, we've been looking at pH. So now you're going to notice with these equations, we have this other thing called pOH. So it's the opposite end of the spectrum where before pH is the power of hydrogen ions. The hydronium ion, same thing. But there's also a pOH scale, which is the opposite of pH. Okay, so now we're specifically looking at the hydroxide ion concentration. So, like I said in part 1, things would get easier. And this is where they start to get easier because of one of these particular equations. Up until this point, we've been using the Kw formula to go between ions. Now we can use a different formula to change ions. And to be honest, this is the way that I like to do it more, so you guys find the way that you're familiar with. And then I'm going to show you both methods once we get through it. So how pOH is compares to pH is it's based on the bases, okay? So the bases have the low numbers and acids have the high number because, again, the ion of choice that we're looking at is hydroxide, which should make sense because it's bases. So you might be thinking, well, how this is going to be so confusing. Guys, you know pH. You have much more background knowledge regarding pH from prior classes and things. So you can always get things back into the pH scale, and I encourage you to do so. So these last couple of equations that we're going to look at are going to make things a little bit easier. So pOH equals the negative log of the hydroxide. So this looks familiar mathematically, guys. We've already done this. This is using the same formula as our pH formula, but now instead of having to switch from the hydrogen ion, or excuse me, the hydroxide ion back to the hydrogen ion, we can just use the hydroxide ion. So if we have a base, it makes things a little bit easier. We can also do the opposite, and we can go from the hydroxide ion concentration, from the pOH to the hydroxide ion concentration using the anti-log. But this last one, this is the big one right here. Maybe you've heard this or seen this before, but this is that one that's going to be the most helpful and most useful because you no longer have to use the Kw formula if you understand this. And to be honest, guys, I like this way better. I don't even use Kw when I do these calculations. I show it to you so that you guys know where it's coming from and kind of the background theories with it. But when it comes to the application, we can just use this. pH plus pOH equals 14, all right, which is the same thing as Kw. Kw was hydroxide ion times the hydrogen ion concentrations equals 1 times 10 to the minus 14. Notice, guys, the 14, we've said if it's a perfect base 10, that, it just becomes that number. This is the same thing, except when it comes to logs, we don't multiply them, we add them, okay? And that's all we're doing here is we've taken the log of our concentration numbers and we add them up to 14. That's how they all relate, okay? So I'm going to work this problem out here both ways that you could do, okay? So from here on out, any pH problem or pOH problem, guys, there's 2 methods that you could use to figure this out. And there's on page 19, your next page in your packet, what I've given you is kind of a roadmap to kind of show you that. So if I'm here with pOH, I can get to pH one of 2 ways. I can take the short route and go one step and just subtract from 14, or if I wanted to, if it's easier in my mind, so this is where you have to make that choice. If it's easier for you to do this and just go back here, there's 1 step, 2 steps, 3 steps. It's up to you how you want to do. There's always going to be 2 ways to solve a problem to go from point A to point B. So this is going to be a very helpful tool for many of you when things get mixed together, like in your next practice. So here we go. I'm going to kind of work this out. If you feel comfortable and want to pause it, I encourage you guys to pause this, but otherwise you're going to be getting lots of mixed practice when you do the next practice in your packet. So here we go. All right, so I'm looking for hydrogen ion concentration. I have a solution with a pOH of 8.2. So the first method I'm going to show is kind of the old way that we've already done it. So up until now, we have pOH, so I can then get from pOH, I can figure out my hydroxide ion concentration. Actually, yeah. When you look at the answer key, in my notes, if you're doing it that way, these methods can be flipped, but that's okay. Again, either way works. So pOH, 10 to the negative pOH is how we get that concentration. So this would be 10 to the negative 8.2. And when I do that math, I get 6 times 10 to the minus 9th molar. Now, did that get me to where I wanted to be? No, because I want hydrogen ion. So to do that, I'm going to use my Kw like we've used before. So Kw over my hydroxide ion concentration. So this is 1 times 10 to the minus 14 divided by 6 times 10 to the minus 9 that I just calculated. When I do that math, I get my hydrogen ion concentration to be 1.67 times 10 to the minus 6 molar. So that's one way that you could do it. If you're more comfortable doing it this way, go for it. Sometimes students will like it more this way because it's the first way that they've seen using Kw versus the other method. Now, me personally, I like method 2 that I'm going to show you here better, but again, find the way that works for you. So all we really have to do here is we can take the pH, we can figure out pH from equation 6. So if I do that, that's 14 minus the pOH. All I've done, guys, is I subtracted my pOH here to get the pH by itself on one side of the equation. So pH here is going to be 14 minus 8.2, which is going to give me 5.8 when I do that math. And now all I have to do is H plus concentration equals 10 to the negative pH. So 10 to the negative 5.8. And when I do that, I should end up with the exact same answer. Now, they might be slightly different just because of rounding purposes, guys, but all in all, they're the same. So this is 1.6 times 10 to the minus 6th molar. Okay, so either way you get to the same answer, but there's two routes that you can go. So as you're going through your practice after this video, utilize this reference table. Now, is this resource going to be on your reference table? No. Are you going to be given this on a test? No. But if you wanted to practice this and write it out and kind of memorize this, that's up to you. My encouragement to you guys is to know the formulas and then be able to kind of navigate it just by looking at it. But if it helps you to draw it out, you know, the best way to practice to memorize this is just write it over and over until you know how this is, and then you can write it on a test or a quiz. Now, the other piece that we need to talk about here with pH, and we saw one of these actually last year on last year's June Regents exam, is how many times greater, okay? So you've got to be able to compare two different pH values together, how many times more acidic or basic, okay? So when we talked about logs, it's powers of 10. So each pH change you do is a power of 10. Okay, so really what you want to look and see, okay, well, what's the difference? So number one here, first off, it's going from a pH of 3 to a pH of 4. So is that going to be more basic or more acidic? Well, it's increasing pH. That means it's more basic. So that's going to be kind of the first thing. This is going to be more basic, so I'm going to write that down. Now we want to figure out how many times more basic it is. So what was the change here? Is it really 1 times more basic? No. Every time you move something, guys, from one pH value to another, so if I go from 3 to 4, that's really 10 to the first power. Okay? Now, 10 to the first is just 10, so this one is 10 times more basic. Okay? So if I move every one increment along the pH scale, it's 10 times more acidic or more basic. So if we look at number 2, let's think first. 2 to 6, okay, that's going to be more basic. Now, 2 to 6 is how many? So 2 to 3 is 1, to 4 is 2, to 5 is 3, and to 6 would be 4. So this is 10 to the 4th. So we got to make it 10 to the 4th power. When you do that math, that equals 10,000 times more basic than what it was. Okay, so this is how you solve a problem like this. Again, we saw one last year on the June Regents exam, so there's a good chance that you could see something like this. So make sure you go through and practice this. If you want extra practice, let me know, but we will come back and review this definitely at the end of the year. So I encourage you guys, pause this video now, go through and try to figure out the rest of these on your own. So 8 to 5, that's going to be acidic. That's 10 to the 3rd, which is 1,000 when you do that math. This is 1,000 times. It's becoming 1,000 times more acidic. All right, so this next one is going to be basic because we're increasing our pH. This is 10 to the 6th power, and when you write that out, it is, hold on, 1, 2, 3, it's 1 million times more basic. All right, you can do the same thing all with the rest of them. I'm going to kind of go through and just say if it's going to be acidic or basic. That's kind of the easiest part. All right, this one is going to be basic, and this last one is going to be basic as well. All right, so this is 3, so 10 to the 3rd equals 1,000 times more basic. This is also 10 to the third. It's just a different change in pH. So this is still 1,000 times more acidic. I'm sorry, I said basic here, but this is more acidic. So if we're going from a higher pH to a lower pH, it's acidic. If we're going from a lower pH to a higher pH, it's basic. All right, so this is 10 to the third again, but it's the opposite. It's going to be 1,000 times more basic. And this is 10 to the fourth, which equals 10,000. All right, so up until this point, we have done all the types of calculations. We've learned about those. So what you guys want to be working on now and focusing on, take the next day or so in class to do a bunch of this mixed practice. So at least do this practice page where they're all mixed together. Be able to identify, ask yourself first, is it an acid or a base? And then from there, figure out what ions you have, okay, within the concentration, and then start to navigate these formulas right here using that roadmap that I gave you, as well as just your background knowledge, and then try to figure this out, because this is what you're going to have to do on your pH calculations quiz. So definitely take a day or two in class, like 1 or 2 periods in class to practice this, and you can start taking the pH calculations quiz on Wednesday or Thursday of this week. Till next time, I'll see you later.